Hey everybody, Mr. Perry here. We're talking about having equations that have variables on both sides of the equation. So again, we have another equation here where we have a lot going on. I see a little bit of distribution on the left side of the equation. I see some combining like terms on the right side. I'm going to take it step by step, try to get it all done. I'm going to start off by doing the distributed property. So I got the 6 over here, and I want to make sure that I understand that that 6 is getting distributed to everything inside the parentheses. So only the left side of the equation is really affected here. I got the 6x, and then 6 times 4 would be 24. Everything on the right side of the equation stays the same, which is nice. I got 4x plus 2x minus 12. So we did some distributed property right there. Now I'm looking at this equation, and remember now I want to come to a final spot where I can start maneuvering some things around, where I have variable constant on one side, a variable and a constant on another side. And again, on the left side we have that. We have a term with a variable, we have a term with a constant. We don't have that on the right side. We have the 4x plus 2x. So we have two variables on one side. Let's go ahead and combine those like terms. So I'm looking specifically on the right side of the equation here. 4x plus 2x would be 6x. We're not going across the equation. We're doing an operation on the right side only. We're not going across the equation. So we just take it for face value. 4x plus 2x is 6x. And I got a minus 12 over here. That doesn't change at all. On the left side, still have 6x plus 24. In that step right there, of course, we did combining like terms. Now, we're at that spot. We have variable on one side, we have variable and a constant on one side, a variable constant on the other side. I like to maneuver the terms with the variables first because I want to eventually kind of see what I'm dealing with. You should notice at this point, I have a 6x here and a 6x here. They're both positive. So let's just hypothetically say I want to have it on the left side of the equation. So I'm going to subtract this 6x, and I'm going to do the inverse operation here because I'm going across the equation. And 6x minus 6x is 0x. So in that case, we usually like that because that would give us a negative 12. That gives us only one term on the right side of the equation. On the left side of the equation, you might notice already, 6x minus 6x, it's the same exact thing that we just did on the right side. That makes 0x. And 0 times anything would just be 0. So just like it did on the right side, those 6x's are no longer available to us. We don't have an x in the problem. All I'm left over here on the left side when I do 6x minus 6x and get 0 is I have a 24. So in this scenario where both sides had a 0x now, I'm left with no variable, and that's a problem for us. So I have no variable here, and I gotta, at this point, take a look at these numbers. 24 is equal to negative 12, and I gotta think to myself, is that a true statement? And last time I checked, 24 is not equal to the number negative 12. So with that being said, we're now going to have a scenario where our final answer is actually that there is no solution to this problem. So we're going to go ahead and we're going to write down no solution to this problem. What that means is that there have been many equations that we'll deal with where there will be one value for the letter x that we could plug up back in here and make it a true statement. But like we said, no matter what, this equation ends up in a scenario where we would not have a true statement. It's always going to be false. And we know that there's no variable here to solve for, which means this is going to be an answer that we put down as no solution. Kind of, sort of a rare scenario for us, but something that certainly pops up and we got to be aware of when it happens. The key here being the matching coefficients for our variables.